Okay, hello again everyone. We have, and I will try and get this right, Chwiejczak with the art of testing in Python. There's some time at the end, he'll take some questions. Big welcome for Jan.
Hi, thank you very much for coming. I work for Cambridge Medical Robotics. We're one of the sponsors of PYCON. You can say hello to us outside if you're interested. There will be code on slides during this presentation. So if you're sitting more than half of the room, you most likely won't be able to read it. However, there is a little link in the bottom there. So if you're interested, you can go and follow that link. This is very much an introductory talk into the testing in Python. So if you never wrote tests before, or if you have very little experience writing tests, you're the perfect audience. Now, on the other hand, if you've been doing that for a while, you might find that a lot of things that I'm talking about are really basic. Right, so let's kick off. Why I have such a picture for our talk about testing in Python? This is a real question. Any ideas? It's a surrealistic workshop. Yes, that could be one idea. Well, I got it because it represents a style of testing. Which of the styles of testing do you think that would be? Unit test. Well, not quite. You see, this represents user testing. Mainly with the Daedalus Wings Limited, and we sold our first pair of wings to Icarus. We haven't heard back from him. We assume everything is fine. That's one way of approaching your testing, but there are other ways. Well, today I'll try to explain the wider picture and the motivation behind why you would like to test your code. And then I'd like to introduce you to it and show that there is nothing magical about testing frameworks, and we can build them up from ground up pretty much, just following common sense. And finally, I hope I'll have enough time to actually show you how to do it correctly using the Python unit test. So, what is the point of testing? Well, automated testing is the best way we have for knowing that your code works. And in long term, it saves time and makes the development process a lot more predictable. It often leads to better design, because if you write tests and you're finding something really hard to test, or you realizing that it interacts with a lot of components in your system, that is probably a sign that you haven't designed that element the best way you could. And very importantly, it removes the fear. It gives you the confidence that the code that you work works and will keep working in future. And finally, I think that's a phrase from Ned Barchedal: debugging is hard, testing is easy. Right, who do we have here? Ideas? Are they having fun? Nah, they're not having fun. We're having a dev team here that hasn't been writing their tests. They neglected that for far too long. And you can see that the deadline is looming, and it's not good. And this is often the way I feel when I know I should have been writing tests, but I haven't. Tests are like flossing your teeth. I mean, you know you should do it, but you perhaps skipped on it. Yes, I know why you could be tempted to skip on them, because testing, honestly, is not easy. It's real engineering, and it requires real effort. But I can assure you, in long term, it pays off. Now, we have a contrasting picture here to the sad dev team. Now, you can see a programmer on a white horse here, and she is equipped with an amazing thing. This is a mythical lance of tests. And it bestows near magical qualities on her. Basically, with that lance of tests, she can proceed fearlessly. She can change the old code and introduce new features without breaking the existing ones. She relies on the safety net of tests to keep the chaos at bay. And you can see the users in the background just swooning on their knees, being so grateful. So this is what we're hoping for. Okay, how we will do that then? Well, I'll show you how we can test code, and then I'll make a quick detour to tell you about the important principles that undermine all testing. And finally, I will introduce a framework in Python which automates a lot of that concerns away. Right. Code coming. We are hired to write a tracking system for the cargo on a ship. So we have our little class ship. It's really quite simple. It has only one attribute, cargo, which is a list, and two methods, load and weight. Load method will be called with the name, quantity, and a weight of a particular cargo. And then the weight method will return to us the total amount of cargo that is on the ship. Right. Well, we can just fire up the REPL, we can import the ship from it, and we can do some testing. So here we'll initialize an empty ship, and then we'll ask for weight. It's 0, is exactly what we expected. We'll load a couple of lions, each of them is probably 190 kilos or so, and we can ask about the weight of the ship. And then we can finally load about 20 African swallows and ask for the weight of the ship again. Now, what is good about this approach? Well, we're testing our code, yeah? But that's pretty much it. It is time-consuming. We can't easily repeat that. And how do we know it is correct? So, one good quality and 3 bad ones. I think we can improve. We're programmers, so we're going to stick that in a script, yes? All of those lines which we put on the REPL are going to go into a little Python file which we're going to execute. Now, this is better. So we're still testing the code, but in a repeatable fashion, and it doesn't require much effort. But the last question which I had, well, is it correct? Are the weights which we're having there actually what we would expect to have? Well, we don't know. We can improve on that. In our next script, we should be not only printing the weight which we loaded, but we'll also tell the user what the weight should be. So after we load 2 elephants, each of them 3.5 tons, the weight is expected to be 7 tons. Now, repeatable, low effort, results are explicit, but checking is still a manual process. Python can help us out. We have an assert statement in Python which takes a condition and evaluates it. If the condition that follows the assert statement evaluates to true, the code just skips to the next line and carries on executing your program. However, if it evaluates to false, an assertion error will be raised. So this way, we have all of the good qualities that I mentioned, and we know that the code is correct and verifiable. Okay, we're done, yeah? Not quite. Of course, we have the assertion error now if we mark the tests up, but what you'll notice is that the output is somewhat cluttered, and testing has stopped as soon as we hit first problem. So we won't know what happened with the rest of our tests after there is one that is failing. So by now, you should have sort of like buzzing ideas in your head. The problems which I'm describing must be extremely common. And if there are common problems, then there must be a consistent way of solving those problems. And if we have such a consistent way, then we can easily share it between the developers, and we should have a single standard that everyone follows. And luckily we do. But before I introduce this standard, I'll introduce to you another acronym, which is FIRST. So a lot of the time you will hear that good tests are first. F, any ideas what it stands for? Fast. Tests should execute quickly. If they're slow, then wouldn't be run frequently, and then we won't have much benefit from them. I. Independent, yes, that's a really good one. But I go with informative. They should tell us where the failure occurred and where to go and fix the code. Oh, damn. Okay, but you would get that one already. So the fourth letter S is actually really hard to get. Any ideas?
Sensible.
Strict, sensible. I like both, actually. Specific was another good one. Self-verifying I'll go with. That's the quality that we don't want to be checking the output ourselves. It should verify the output itself. And last, T. Oh yeah, like that. Timely. That's a bit disappointing. What does it even mean that the test should be timely? Any ideas? One way of looking at it is when we speak about tests and we say they're timely, that they shouldn't happen the action of writing tests should happen close to actually writing the code. Maybe before you wrote the code or after you code. But if you write tests long time after you wrote the code, because somebody told you to do so, you're not going to have all of the benefits that the tests provide, like better design. And hence, I think this is an important quality. Okay, how are we going to do it in Python? We're very lucky in Python land. In standard library, we have a great module called unittest, which allows us to pretty much do any testing we would imagine. And this should be taken for granted. There are many languages out there. If which you come to them, you first have to figure out which test framework to use or whether there is a test framework for them. Right, how we can write our first test using that framework. All of our tests will now live in a class which inherits from unittest test case, and by convention, there will be a named test in that class. And the test itself will be methods of that class, and if that method is to be executed as a test, it has to be prefixed with a word test. Otherwise, it won't be found by testrunner, which is the thingy that is going to run those things. Here we have a very simple test. We're going to load a couple of elephants, and then we're going to call a method of that unittest test case class to assert that the weight equals 7 tons. And if we run that, we can run that by doing Python -m unit test and then our test class. We will get 1 dot for our effort. That means 1 test passing. Okay, what's happening behind the scenes? This is interesting. We're gonna initialize a new instance of the ship test class, and then we're gonna try to run our tests inside a try except clause. And we're gonna record failure or record success. And because it's in that try except clause, we are already addressing that very important problem that the failure in testing shouldn't stop the whole of your test suite. The rest of your test suite will run fine, but that individual test will fail. Okay, let's add a couple more. We're going to be testing whether an empty ship is in fact empty, and then we're going to be loading some cargo on it. And you quite quickly can see that the tests follow a similar setup stage. You first arrange certain things to be in place, like you arrange for an empty ship. Then you do something on that, like you load a couple of elephants, which is the act step. And then you finally assert. And all good tests, you should be able to quickly identify those 3 steps. Arranging something, acting on that, and then asserting that what you acted on is indeed what you expected. And if we run that, 3 dots, 3 tests passing, great. Now, let's break that middle test and see how a failure looks like. Giuseppe Arcibaldi, he made a living from painting portraits indicating people as an everyday objects. And here we see how our failure looks like. We have 3 tests, 2 dots for passing test and 1 F for a failing test. And the reason for the failure is very clear. We have an assertion error. We've been expecting 7 tons, we got 8. So it pinpoints the area of our code that we need to go and fix. Results are clear, failures didn't stop execution, and output is not cluttered. And what happens inside, again, very important, we're going to have 3 times 3 independent classes of our tests, instances of the classes of our tests created, and each of our methods of that class will be running its own try except clause. And why are we doing that? Already somebody mentioned that. This is a very important property of the tests. And it's somewhat captured on that Edward Hopper work. He was a prolific American artist that captured the sort of urban loneliness and desolation. And what a property of the tests I'm talking about? They need to be isolated. Exactly right. Tests need to be isolated from one another, and that's why we created those 3 instances of that class. And only by isolation will ensure that one test does not impact another and that the failure does not stop the test execution. And you should treat your test code as a real code. So if you see that there are opportunities to simplify something, you should perhaps pull those things into a class your tests will inherit from. So customizing your base class is a really good way to introduce the domain language into your code base. So here, rather than calling the assert equals method of the unit test case, we will call now assert weight equals method, which we just coded up there. And a third option, we can have a test passing, we can have a failure, which we saw. Third option is an error. An error basically means that, well, you broke your code, doesn't work. You got an assertion other than the assertion error happening in your tests. And we can actually test specifically for the errors as well using a context manager, self-assert raises, and then we're gonna run the code which should raise that exception. Now, why do I have a hamburger here? This is a very far-fetched one, I give you that. But context managers are bound to the meat of our function. So they encapsulate our functions. They run something before it and after it, and it's a reusable bun. So you can slide whatever you want inside. And it's a really important way of thinking about context manager, or at least the way that I think about them. And we're going to add a new method. We can now unload some cargo from our ship as well. And I won't go through that code, but trust me that it does what I say it does. So we'll load a bunch of things on our ships, and we'll have 3 tests. We're going to load some lions, we're going to load some elephants, and we're going to load some T-Rexes, and we're going to realize there's not enough room for the T-Rexes, so we're going to have to get them off the board, unfortunately. So is that good code? We have, or are there any problems with it? I'm not sure whether you can even see it. Absolutely, there's a lot of duplication, yes. A lot of those things should be kind of abstracted. And it's a common problem with the tests, which is solved by something called setup or fixtures. Now, those 2 chaps on the right have a fantastic setup for cutting that log. You can see that the way they arrange it, they can really do some serious cutting. And we can do a similar thing. We can have a special method, which we're going to call before other tests, and then the tests themselves become a lot nicer. Now, I'm slowly running out of time, so I'm going to skip forward a bit. What I'd like to say is tests are real code, and you should learn to respect your test code base. You should take time to write helper functions and to abstract into base classes. And fixtures are a great idea to get a lot of that repeatable code out and to reuse them. And there's some fantastic fixtures libraries out there as well. And if you do that, then your test suite will become a fantastic way to document your code, and especially for a new developer, to be a really gentle introduction how your code base works. And it's an extremely rich subject, testing, and there's a load and load to explore. Couple of bullet points for you to take away. Coverage is a great tool. It's basically going to run your tests alongside your code, and it's going to tell you which lines of the code were executed and which were skipped. Hypothesis is another powerful tool, which is basically a property-based testing rather than a testing in which you give it a value that you know is going to be equal to. PyTest is arguably a lot less boilerplatey option to the unit test. And then finally, you can even have tests in your comments thanks to the doctest module, or automate your browser if you're developing for web with something called Selenium. There's a lot more. Once you start the slippery slope of testing, something called TDD will quickly crop up on your agenda. And it's basically an idea of writing the tests first, and it's a good idea. And there's some other ideas as well. Maybe tests should be written in a way that can be read and understood by product managers, and that's behavior-driven development. We can write tests in plain English using things like cucumber or lettuce. And then we can also think about integration testing, which is testing a bigger portions of your system, or continuous integration, which is basically running your tests all of the time. And rather than leave you with a bunch of resources, I would recommend two. There's Test-Driven Development with Python by Harry Percival, which is a great book that's going to introduce you not only to test-driven development, but also to web frameworks and a host of other subjects. And there is a great talk by Ned Balchadar called Getting Started Testing. He goes in a lot more details than I do. And as Oscar Wilde say, imitation is the most sincerest form of flattery for the mediocre ones to the great ones. And I took a lot of ideas from his talk. So I think it's well worth looking at that. So to summarize, I think testing is a real engineering challenge. It's good. It's a real problem. You are trying, if your code is any sort of if your code has any sort of complexity, writing a test suite that will assert whether it's correct is a near impossible task. And this is an extremely cool and extremely challenging task. So I find it personally a very stimulating thing. And this is important because this is the only way we can go home and knew that what we wrote actually works. And it's a real craft. And those two chaps there, Jean de Danteville and Hervé de I forgot the other chap's name, are two ambassadors to the Tudor court. I particularly like that painting. There is a funny thing hidden in it, which is an anamorphic projection of skull in the center of the painting. But if you look from the top right or the bottom left, that's what you see. And he painted it by hand. Staggering. Right, I would like you to leave today with a positive image. That is a team that has been writing their tests. They seem quite happy and content in their life. They can sit outside and enjoy the sun rather than fight expensive fires. And that's me. Thank you very much for coming.
Thanks, Jan. We've got time for a couple of questions, if anybody has any. Yes, very well, one sec.
Thank you. So you mentioned there are some libraries for fixtures. Could you give us a quick example?
When you're being put on stage and you're thinking there's that thing at the end of my tongue and it completely skipped my mind.
Yeah, Factory Boy.
Thank you very much. Anyone else, any good ideas? That wasn't the one that I was actually going to mention. There is another one which I even recently used. Oh. I'll check that in a second and actually come back to you.
Any more questions at all?
The teardown module, the teardown function, when is that useful? Could you give an example?
Yeah, certainly. If you're setting up for some resources like database access or files, and if, for example, committed certain transactions to the database, but you don't really want them to be in the database, you want to roll them back, teardown would be exactly where you put that roll back in. So this is going to be executed every time you sort of test finishes, whether it actually failed with an assertion or whether it ran through. So it's a kind of a guaranteed way that whatever you change with the system, the resource is going to be cleaned up properly after you.
Cool, thanks very much. Big hand for Jan.